Good morning, students. In today's lecture, we will be talking about transactions, transaction systems, about testing of serializability and the serializability of schedules. Right. So, without wasting time, we will start with the lecture. So, to start with, first we need to understand what is a transaction. So, basically a transaction is a unit of program execute or it is a program under execution that accesses and possibly updates various data items. So, when we talk about operating system, we talk about processes, right. So, transaction is also a similar term which can be used in place of a process, and it is a single unit of execution. We all can also call it a program under execution, and when we talk about transaction, it has a very specific characteristic, and the characteristic is that it is going to access and update some data items that are stored in some database. So, whenever a updation is made into a database, we will call that a transaction, right. So, over here we are taking an example to show how transaction works. So, this is basically a transaction where we are trying to transfer $50 from account A to account B. Now, this is a single transaction which will be taking out some money from account A and putting some money into account B. So, over here you can see the first instruction in this transaction is a read instruction. Now, what is this A? A is a data item. This is a data item. That means, the value of A is stored somewhere into the database, right, and we are reading that value of A into our transaction, right. Then once we have read the value of A, we are debiting $50 from A, right, and once we are done with this updation, we will write the value of A back into the database, because the changes cannot be automatically done in the database. We need to read it, make updations and write it back. So, this goes back into your database, right. Now, because it is a transfer of an amount from one particular account to another particular account. So, now we have to read the value of the second account, that is account B. So, we read the value of B, then we update the value of B, we make changes into the value of B and then we write it back again into the database. So, this is a transaction where we are reading something from the database, making updations into it and we are writing it back. Now, when we talk about such type of transactions, there are some problems that we face when we talk about different type of database, different type of transactions that are taking place at the same time. So, the problems that we face when we talk about transactions, there are mainly two issues that we will be facing. The first issue is failure of various kinds, such as hardware failure or system crashes. So, what happens whenever such type of failures takes place? If the transaction has completed, that means all the updates have been made and after that a failure is taking place, then there is nothing to worry about. But if the failure takes place in between the transaction, then what happens? The database goes into a inconsistent state. So, that is a problem, right. And the second issue that we have when we talk about databases and transaction, we have the issue of concurrent execution of multiple transactions. We all know that right now we are in the era of multiprocessing. It is not possible that we process only one transaction and all the resources are waiting for that transaction. and all the other transactions are waiting for the first transaction to complete, right. So, that is not possible. So, what happens when we have concurrent execution of multiple transactions? So, the database has to be secured in a manner that it does not go into a inconsistent state. So, this complete unit, the fourth unit of DBMS, talks about consistency, mainly maintaining the consistency of the database. So, these are the main two issues that we face when we talk about transactions. Okay. So, to start with transactions, first we need to know about the ACID properties. You must have heard about these properties before also when you have gone through your operating system syllabus, right. So, ACID stands for four things: atomicity, consistency, isolation and durability. Now, what are these things? To maintain the consistency, to maintain the database in a proper shape, that means there should not be any ambiguity in the database, we have to maintain these four properties of data. Now, what does these things mean? When we say atomicity, atomicity means either the transaction should complete, it should complete the whole thing and make the updates into the database, or it should not take place at all. Now, how is it possible? It is possible that if a transaction is under execution, it completes itself and makes the final update into the database. So, atomicity is maintained, that means the transaction has completed fully. In case there is a failure in between, in that case what we need to do? We need to roll back to the initial state of the database. In that case, we will say that there was no changes at all. So, atomicity is either everything or nothing at all, right. So, the first property is atomicity, which talks about either the transaction should be complete or it should not affect the database at all. Second is consistency. That means, when a transaction is executing itself, it should not disturb the consistency of the database. If the amount in a bank is 5,000 rupees, so in any condition, if there are no changes at the end of the transaction, the amount should be 5,000, or if we are adding some amount into the database, let us say 1,000 rupees, at the end of the transaction the amount should be 6,000. That means, consistency of the database has to be maintained in every condition. The third property, isolation, very important property. Isolation means that every transaction should feel that I am executing, I am getting executed alone, but actually that does not happen, because we are in the concurrent world, multiple transactions are getting executed at the same time. So, practically isolation is not possible, but we have to manage the execution in such a way that we feel that there is a condition of isolation, and when one transaction is getting executed, there is no other transaction getting executed at the same time, right. And lastly, the property is durability. Now, what is durability? Durability says that once you have made changes into the database, it should be durable. That means, even if the system shuts down, the database should not revert back to its original condition, or the value should not change. Even after the final execution, or even after a shutdown, the changes should be durable into the database. So, these are the ACID properties that we need to maintain when we are talking about transactions. Okay. So, these are the ACID properties that we have discussed. Okay. Now, let us come to the next part, which talks about the states of the transaction. So, these are the states that we have when a transaction is getting executed. So, over here you can see we start with the active state, that means when a transaction gets into the memory, asks for the different resources that it needs. So, it gets into an active state. when it starts execution and it has executed the last statement also, but it has not made changes into the database, the final changes are not made into the database. At that state we call it a partially committed state, that the transaction is in a partially committed state. When the last statement has been executed and the changes have been made into the database, we say that the transaction is in a committed state, right. Now, from active state the transaction can also move to a failed state if in case some failure has taken place. In that case what will happen? A rollback takes place, that I was talking about, rollback, so that the database can go back to its original condition. Then from after the rollback the transaction is aborted, it goes into abort state, and then finally a terminated state which comes after the commit as well after the abort state. From the partially committed state also we can move towards a failed state, that means we have executed the last instruction, but those changes have not been reflected into the database. So, let us go into it little bit more in detail. Okay, so, these are the things that you have already seen in the diagram. We say that active state, when a transaction is like it has started or it has been fired in the operating system, by the operating system or by the database manager, it enters the active state, the transaction remains in the state during its entire execution. So, till it finishes or terminates itself, the transaction remains in its active state. Then we have the partially committed state. What is a partially committed state? A transaction enters this state when its last statement has been executed, right, but the updates are not yet made safe into the database, right. So, that is a partially committed state. Then we have the committed state. A committed state tells that a partially committed transaction enters a committed state when it all the updates have been made safe into the database management system, either in the database itself or in the log files which is stored on some non-volatile data, on some non-volatile media, right. So, that is your committed state. Then we have the failed state, which says that a transaction enters the state when it is not able to proceed in a normal manner. So, some type of error has taken place or some other problem is there. So, it is not able to proceed in a normal manner, right, either due to its own internal error. So, it can be possible that there is a internal error, or due to some system failure, that can be like a hardware failure or a software failure, right. Then we have the aborted state. A transaction T enters the aborted state when it has been rolled back, either after a failure, right. This is the state when the failed transaction T has reverted back to its initial state. That means, we have rolled back to the initial state of the database, right, which existed prior to the failure that had occurred, right. So, this is a aborted state where a rollback has taken place, right. And then lastly, for both the commit and the aborted state, the last state is the terminated state. Now, what is the terminated state? It says a transaction is said to be terminated when it has either committed successfully or has been aborted after a failure. In both the cases, it will enter a terminated state, right. Now, if we talk about the advantages, why we require concurrent execution of transaction, we all know the advantages of concurrent execution. You have gone through it multiple times about the advantages of parallel execution, multi-processing, multi-programming. Then concurrent execution in the case of database management system, we all know that it has two major advantages. The first advantage is that the throughput improves, right. And how do we define a throughput? Throughput is basically, let us say, because we are talking in terms of transactions. So, throughput is the number of transactions that are getting executed per unit time. Now, this unit type can be 1 nanosecond, it can be 1 microsecond, it can be 1 second, 1 hour, 1 minute. So, it depends upon the unit. So, number of transactions getting executed per unit time gives you the throughput, right. So, there is an improvement in the throughput. Resources of the computer are utilized in a better manner, and it also reduces the average waiting time, right. So, these are the main advantages that we have when we are talking about concurrent execution of transaction. The throughput improves, resource utilization improves, and the average waiting time of the transactions reduces, right. So, these are the advantages that we have when we are talking about concurrent execution. Now, let us come to concurrency control, because we are continuously talking about concurrent execution. So, there has to be something that takes care of concurrent execution, so that your database remains in a consistent state, right. So, we have a module, right, which is known as the concurrency control module. So, it says that the exploitation of concurrency amongst transactions throws up the issue of concurrency control, right. This control has to be exercised by the database management system to ensure that the execution of the concurrent transaction is developed in such a manner that the concurrent execution is virtually equivalent to serial execution. So, it is the basic idea behind it is that whenever we are talking about concurrent execution, we should feel that it is a serial execution. Even every transaction should feel that it is doing a serial execution, right. So, it should look like a serial execution. So, the system is able to draw benefit of concurrency while presenting database consistency at the same time, right. So, what is the main idea? That we have parallel execution and we can also maintain the consistency of the database. Now, let us talk about execution of transactions. Now, when we talk about execution, we know there are two ways of executing transactions. The first way is the serial execution, in which one transaction is executed after the first transaction has completed itself, right. So, this type of a typical construct is known as serial execution. So, we will take some examples and see how serial execution works. And when we talk about concurrent execution is when we have more than one transactions getting executed at the same time, right. So, let us first take some examples of serial execution, right. So, here there is an example which says that the initial balance of two accounts A and B, A is 5,000 and B is 3,000. Now, this example we will be discussing throughout the lecture, right. And we need to transfer, there are two transactions T1 which needs to transfer 1,000 rupees from account A to account B, and there is a transaction T2 which needs to credit 500 rupees to account A. That means, at the end of the transaction, the value or the money in account A should be 4,500 and the value in account B should be 4,000, right. Now, let us see how it is done. First, we will take example of serial execution where T1 is getting executed before T2, and after this we will see how it happens when T2 is getting executed before T1. So, the same construct is there. T1 reads the value of A, deducts 1,000 rupees, writes the value of A back into the database, reads the value of B, adds 1,000 rupees to B and writes B back into the database. So, you can see over here when we are talking about the changes, the values, the data set that is getting changed. Initially A was 5000, then A became 4000, and when we are reading the value of B, it is 3000, and at the end of the transaction B is 4000. After this, transaction T2 is coming into the scene. So, reading the value of A, which was 4000, added 500 and wrote back the value of A. So, at the end, the value of A is 4500 and value of B is 4000. Perfect. This is what was expected, right. The same structure, only changes that transaction T2 is getting executed before transaction T1. So, over here the changes are being made, right. So, A is getting updated by 500. So, at the end of transaction T2, A becomes 5500. Now, transaction T1 comes in, it reads the value of A, which was 5500, deducts 1000 rupees, puts it back to the account B. So, B becomes 4000 and A becomes 4500, right. So, this was a strict serial execution. Now, when we are talking about this type of execution, you need to understand the difference between these two type of execution. We all know that serial execution that we have seen over here in the example, that T1 was getting executed before T2. Similarly, in the next example, T2 was getting executed before T1, that is in a serial manner, right. Now, we need to come into concurrent scheduling. Now, concurrent scheduling, what happens, that whenever a transaction goes for a IO, right, input output instruction whenever we have. So, the CPU is taken from that transaction and is given to the next transaction, which is waiting for the CPU. So, what happens, there is a interleaving that is created. That means, as soon as transaction T1 goes for a IO, the CPU moves to transaction T2. As soon transaction T2 also goes for IO, the CPU moves back to the transaction T1. So, this is how interleaving takes place. So, when we are having concurrent scheduling, let us see how concurrent scheduling works. So, over here you can see this is the example of a concurrent scheduling. Now, what is happening? We started with transaction T1, we read the value of A, deducted the value of A by 1000, and then we were trying to write the value of A back into the database. So, our IO took place and the CPU got shifted to transaction T2, right, before T1 could have completed itself. So, now T2 is reading the value of A, it is making changes into the value of A and writing back the value of A. Now, over here right now there is no problem, because whatever changes in A was made, it was written into the value of A. So, when we are reading the value of A over here, it is reading the updated value, which is given over here, right. So, there is no issue, but after this what happens, we move to read B, B is updated with 1000 rupees and write B, right. So, in this concurrent execution also we are not facing any problem, because of this instruction that the value of A was written back into the database before we could have moved to T2, right. So, there was no problem and the result was as expected, but when the problem will occur in this situation, right. So, now over here you can see we are reading the value of A is being changed, but before the value of A is written into the database, T2 has read the old value of A, right, which was 5000 rupees for our case, right. So, it is reading the old value of A. Now, what happens? It is read the old value of A and it has made changes into it, it has appended 500 rupees and it has written the value of A as 5500, but T1 has read its own value at the starting of the transaction. So, now what is happening, the value of A for T1 is still 4,000 rupees, because it has read the value of A as 5,000 and it has deducted 1,000 rupees from it. After that, it writes the value of A back into the database. So, now what A is writing, A is being written as 4,000 rupees, that is being written by T1 transaction. Then it reads B, make changes into B, and it writes the value of B back. There is no problem with the B database, but what happened, the consistency of A has got damaged, right. So, over here you can see that A and B both are now 4,000 rupees, which should not have been the case. So, this is a concurrent execution, and because of this concurrent execution we have ended up into a problem, right. Now, when do we say that two schedules are equivalent schedules? So, to end up this whole thing, we need to know what are equivalent schedules and what are serializable schedules, right. Now, what are equivalent schedules? Two schedule S and S dash are said to be equivalent if when executed independently, each of the schedule transforms the database from a consistent state S1 to another consistent state S2, right. So, any schedule, any two schedules, their sequence may be different, right. Their sequence may be different, but any two schedules which are converting from state S1 to state S2, and they both of them are doing the same thing, at the end we are getting the same values, we say that both the schedules are equivalent schedules, right. What are serializable schedules? Serializable schedules are those schedules, we say, suppose S is a concurrent schedule and there exists a schedule S dash which is serial and logically equivalent to S, then S is said to be a serializable schedule. So, what is S? Basically, S is a concurrent schedule, but there is a equivalent serial schedule for this concurrent schedule. In that case, this concurrent schedule will be called as a serializable schedule. Thank you so much.